Aloha, Richard Halverson here. This is ITS148, and today I'm going to do programming project 18.1. So let me share my screen. And here we are, and I'm going to do this, start out with this one right here, 18.1. So when I open up Pearson Revel, and this is what it looks like. And so let's see what the actual problem is. And okay, in this class, we're going to define a new class called myLinkedList, and it extends linked list. And linked list is described in this chapter. And we'll also see it here when we pull down this test program to help test our code. But basically, we're going to extend it by adding some methods, 3 methods. And one method is going to be adding elements from some other list to this list. And it's going to be called add all. And this is, it's going to be adding another list to the existing list. And remove all is going to remove the elements of some other list from the current list, from our list. And the last one is going to do this retain all. And what that does is it goes through your list and it deletes everything except the ones in other list. Okay, so then they give some examples here of a couple of lists. And for add all, we are adding these colors to this list. So we end up with a list that's got all the colors in it, as many times as it has in it. Here's the first list, and here's the second list. And then for remove all, it's going to remove red if it's there. It's going to remove black if it's there. It's going to remove yellow if it's there. And so lo and behold, it's going to remove that one. It's not going to remove green because green's not in this list, but it's going to remove that one because red is one, and it's going to remove black because black is also one. So we end up with just a list of green. And then retain all is going to delete everything in this list that is not in this list. So it's just going to retain, it looks like the red and the black, and would get rid of the green. And sure enough, that's what it looks like here. Okay, so let's see what they give us here. You copy this and go over here and paste and go. And so they give us this linked list class here already. Let's I'm going to copy this out, Control A, copy, and then I'm going to go to my test.py and do paste. So here we are. And so we're given this linked list class, and it can do a bunch of stuff. It can you can add an element to the list. You can insert an element at a particular index. Let's see, we're going to be using add. We're going to be using remove. Just is there a plain old remove? We'll use this removes the first. No, this just removes the head node. Add last. Well, anyway, let's remove last. Remove the last node. Remove the element at an index. Okay, so that might be, here's remove. Okay, so here we're going to remove an element. So we will be using add and remove elements because what we're supposed to do is make an add and remove list. So we'll probably take this and do it, add them one element at a time. We'll loop through this list and add each element of that list to this one element at a time. We'll loop through this list and check to see if each one of them, remove this one. Let's see, how does remove work? Okay, so it first checks to see if that element is actually in the list. If it's not in the list, it doesn't do anything, just returns false. But if it is in the list, it removes it. So I guess it maybe just removes one of them. So, okay. So anyway, so let's see. I don't need this anymore. But let's copy this here. I'm going to copy this, and I'm going to put it up here at the top, just so I kind of have some sort of because it's got some examples in here I want to use. Okay, so I'm just gonna put that there. That way I don't have to refer back to this thing in case it goes away. All right, so what we have to do is we have to go down here where it finds where we enter our code, and that would be right here. There's this, if you scroll all the way down to around 250 or so, there's begin Revel submission and end Revel submission. In fact, it tells you that right up here. Here's the template. You have to find these two lines and you have to put your code inside there. All right, so we have right here. So my linked list. Let's start by, we've got the class list there, and we're going to have to create an init. And when we call to initialize our new linked list class, or create an object from our my linked list class, we are really just using the linked list init of the class that this class is derived from. So we can just do this, and so when one of these is initialized, it actually calls the initialization of linked list up here. So this thing up here, so this linked list is created, and what's created is we have a head property that stores the location or points to, or stores the address of a head node, and one of a tail node, and a size value which keeps count of the number of items or elements in the list. All right, so so we have this. So that is the init, and then we're going to want to add. We're going to want to add. I'll just go back to here. We're going to want to add this. And we're going to want to add, this. I'm just going to do Control C, Control V, and Control C and Control V. All right, so the first one here is going to be, we're going to just stroll on through this list one at a time and add them onto this list. We have created, okay, let's just do that. For element in other list, so that's the list what we want to attach on. We're just going to use the add method that I showed you before. So it's just self.add, and it's the element that we've grabbed off. So it just goes through the element list, or it goes through this list at one element at a time, starting with the first one, and it connects it up to the self, this list, the list that's owned by this. In other words, we're using not remove. We're going to use remove in a moment. It's add, wherever add is. There's insert add. Where is add? I know I probably buzzed right by it. But it's way up at the top. Here it is. Oh, it just adds it on to the end of the list. Okay, so it's taking too much time. Okay, so it does that, and and then we're done. I think that's all we got to do. Yeah, so that's that, and when it's done, we can just return, I guess. And let's see. So and then remove all would be just something like for element in other list. What we want to do is we want to we want to do is okay. So there could be more than one of them in there. So we're just gonna instead of self remove. That's what we would do if there's only one, but there's not. There could be more than one. So we have to have a while loop. While self remove does remove. What does this return? Does it return a true? Oh, it's either going to return a false or it's going to return a true. It's going to return a true if it actually was able to remove something. But if you tried to remove something and it wasn't there, that means that there was no index for it, then it's going to return a false. So we can use the fact that if this was able to remove an element, it's going to return a true, so we can try again, and we can keep on executing the remove until it returns a false. And when it returns a false, it means that it wasn't able to find the element. And so that's what we're going to do here. We can do while we actually are able to remove something, do it. So while, let's see, while this returns true. Now, turns out in Python, you need to, if you start a while loop, you have to put something there. And so you can't just leave it blank, because it's not going to know. You'll get a syntax error. So you really need to put a statement here that really does nothing, because it doesn't really matter. We're just looping. We're executing this. We keep on executing this until it returns a false. We could just maybe it makes more sense to do this. LP, keep on looping. Loop equals self dot remove ELE. While loop equals true, then loop equals self remove ELE. Okay, so this removes the first one, and if it returns a true, that means it found one and removed it. And then while it's true, it's going to try it again. It's going to execute it or remove again, And if it returns a true, then it's going to be true and it's going to keep on going. But once it returns a false, that means there's no more left to remove, and this will not be true, and then it'll go on. And when we're done, we can just return. No, we want to return here, because we may want to be removing more than one element. Of course, we're removing all the elements of a list. All right, great. So that should work for remove all. And then for retain all, that means you're gonna delete everything for element in this list, for element in self, for each element in self, if now we want to see if the other list contains, if we want to see if the other list contains this element. If the other list contains the element, then we're going to leave it alone. If the other list does not contain this element, then we're going to want to delete it from self. And so to see if an element is contained, I believe there's a method for that. And let's see, insert, remove at, get first, contains. So it checks to see if there's an index for this element, and if there is an index for this element, in other words, it'll be greater than or equal to 0, then it's going to return true. So this will return true if the index exists. It'll return false if it does not exist, because the index will return -1. So there is a contains, and so that's what we'll use down here. And if self contains ELE, no, if other list, if other list contains ELE, no, okay, so if this is false, then we're going to delete it out of self. So self remove ELE. I think we've got to do the loop thing again too, because there could be more than one of them. Now, if each one, if it's in, so no, it'll be fine, because it'll come around again. If there's if there is more than one of the same in ELF, it will catch it, because we're just looking if that element exists in other lists. So we don't need to have a loop. Okay. So I think that might be, let's remove. If other list contains false, I think this is a different solution than what my solution that I have right here is different than the solution in the book that they provide me actually has a loop here, where there's a while loop just like this again, but down here. I'm gonna test this, and let's see if this works. Okay, I think that's all I need. Let me save this. And let's just try to run it. Let's see, CD desktop, Python test.py. Let's see if this works. Yes, it does. List one. Let's use, is this still up? Yes, it is. Let's just use this list for the first one. Copy, paste. And let's use this list for the second one. Paste. And let's see, red, red, black, green, red, green, red. Okay, so I ended up getting the same answer. Yeah, I think my solution is right. I don't think you need to have another loop right here, because the actual self remove. No. Yeah, this thing has this being a while loop. Same kind of while that's up here, but okay. Anyway, yeah. All right. Now we actually aren't done yet, because what this thing is asking us is return true if the list changed. Okay. In other words, if the list doesn't change, don't return true, or return false. So so we need to, and right now we aren't returning anything. Okay, we aren't returning anything. So what we have to do is, it looks like if ever the list changes, we need to return true. So and all of the things we're doing, we're either adding or removing. Okay, and this in here we're either we're doing nothing, or no. Here, if we change the list, it's only going to be removing. Here, if we change the list, it's only going to be removing. The new list is only going to be smaller. It can't be bigger. Here, the same thing. Here, if the new list changes, it's going to be bigger. Okay, it's not going to be the same size of it, because you can't take in none of these are you taking away and putting in. You're just either only taking away or you're only putting in. So the way we can tell if they've changed is if the size is different. So if we capture the size here, let's say start size equals self get size. That's a method up here. It's a method up above here. Right here, returns the size. And then we can do here is we can return start size is not equal to self get size. Okay, so this value, this number will be after anything has been added. And if nothing's been added, it's the same. It's the sizes are going to be the same, and they're going to be the same list. It's going to be the same list. We can do that for that one. We can put. Let's do the same thing for in this one and in this one, and then we can return this one also. Oops, forgot to return. Oh, I never had a return here. I guess it doesn't matter. I guess you don't need a return. It's going to return anyway. when it's done, it's just going to go back to where it was called. All right, so uh, now, how do we test this? Well, let's see. Here we are. Look at this. This thing this now returns a value, but it doesn't go anywhere. So I'm going to say changed equals that. It's true if it changed, right? True if it changed. Okay, so change, so that's going to be true. So then I'm going to display out whatever it's going to be true or false. Changed there, and I'm going to say this one changed equals that, and then I'm going to write it out. And then in this one, I'll do the same thing. And in this one, I'm going to write it out. Okay, so let's see what this looks like. Okay, so let's go back to here, and let's put in, let's start with this same list again. And then let's put in a different list. Let's test. Okay, so remove all. So if I put colors here that are not in list one, if I only put colors that are not in list one, then remove all should return a true. It should changed. Changed. It's true if the list changed. Yeah. So it did not change. It did not change. See, am I doing this right? If it changed, yeah, I am. Okay, so let's just see what it says. Let's just see what happens here. So I'm going to put yellow, blue, and purple. Okay, so so it's true that it changed because yellow, blue, purple. It's false that it changed because it's the same as it was. And here it's true that it's changed because, ooh, what happened? Something didn't finish. No, I didn't finish printing out the list retainer. Oh, because it would be empty, I guess. Because there would be nothing to retain. Oh, but then it did. Oh, yes, and it did change. That it would have changed. Okay, my linked list. That's interesting. Let's see. I'm going to run this again. It's weird that I think it's weird that. Okay, red, green, red, black, and for list 2, I'm just going to say blue. It's interesting that it doesn't print out the rest of this thing. Well, I'm going to test this out by actually submitting it. So I'm going to, does this look like everything? Okay, so let me take this and copy it. Let's see, copy, and I'm supposed to just submit my linked list class. Let's see if this works. Okay, yeah, I guess this works. Okay, our little error here, why it didn't print out the right bracket when the list was blank, who knows what the problem was there. But anyway, so that should help you through 18.1, and thanks for watching.